Venus's surface has hellish acoustics, nearly 465 degrees Celsius and dotted with mountains and volcanoes that rise towards sulfuric acid clouds characterizes this intolerably hot place. The atmosphere is under intense barometric pressure, almost similar to being 1,500 meters underwater, and clouds are being driven across a murky yellow sky by fast-moving winds. For rovers and probes designed for exploration, Venus might as well be hell. We send our landers to perish there. Mission lengths are measured in minutes rather than months, since the conditions are so severe and hostile. The explanation is straightforward. Venus destroys electronics, or more precisely, its heat does. Little was known about this planet before the Soviets turned their attention to Venus and began their exploration. You're watching a full-length 4-hour documentary diving deep into what the Soviets found on Venus and the secrets they kept hidden. At a lofty distance of 34 million miles from Earth, many people consider Mars to be the younger sibling of our planet. Venus, however, is considerably closer to Earth at the closest point in its orbit, being 25 million miles away. In terms of size and mass, Venus and Earth are nearly the same size, while the red planet is only about half as big as Earth. With the exception of a Venusian moon, it appears that Earth and Venus were once twin sisters at some point in their histories. Even the possibility that Venus may have had water up until 700 million years ago has been raised in a 2016 paper by NASA scientist Michael Way and his team. If so, Earth might be traveling in the same direction as Venus. That being said, there are still some distinctions between Earth and Venus, a knowledge that was mostly gained as a result of the Soviet Union's research on Venus. It is common and correct to praise the Pioneer and Voyager probes as historic interplanetary achievements because they were deployed by the United States in the 1970s to study the outer planets. This is partially due to the Pioneer plaque and the Voyager Golden Record, which are fitted with the claim that they may one day be discovered by aliens and will facilitate their easy assimilation into the general populace. Similar to human explorers, robotic ones like the Viking landers and the Sojourner, Spirit, Opportunity, and Curiosity rovers receive a ton of attention and are frequently given human characteristics. However, the grandiose Soviet exploration expeditions of Venus have almost been forgotten. The Soviets started developing a series of Venus probes in the late 1950s, at the start of the 1960s space age. As part of the Venera program, they also constructed and operated the interplanetary spaceship for close to 30 years, accomplishing some very remarkable feats, even by today's standards. The space race was in full gear, and the Cold War was in full force in the early 1960s. In all spheres of spaceflight, the Soviets were keen to claim as many firsts as they could. They could carry heavier loads than the United States could at the time. This made it possible for them to construct and launch bigger manned and unmanned spacecraft. The Soviets could also launch missions to the challenging inner planets using 4-stage rockets and a sophisticated telemetry system. The first probe in the Soviet Venus mission series, Venera 1, weighed an astonishing 1,400 pounds at just 184 pounds. The first satellite, Sputnik 1, was a mere featherweight in comparison. The Venera 1 probe, which resembled a Dalek from Doctor Who, was equipped with a magnetometer, Geiger counters, and micrometeorite detectors. It was also spin-stabilized. In order to keep the instruments operating at a steady temperature, the interior of the probe was pressurized to just over 1 atmosphere with nitrogen gas, like many of its successors. The initial Venera 1 probe, nevertheless, was never able to leave Earth's orbit, and the second effort, which was launched on February 12, 1961, was unsuccessful while traveling to Venus, despite passing the planet at a distance of around 62,000 miles, 100,000 kilometers. Built to fly past Venus, Venera 2, which was remarkably similar to Venera 1, would record data and communicate it back to Earth. On February 27, 1966, the probe finished its flyby and came within roughly 15,000 miles, 24,000 kilometers, but it likewise overheated and was never seen or heard from again. Venera 2 may have crashed before or after it zipped by the far-off world, but this is still unknown. The next 4 probes, Venera 3 through 6, were created by the Soviets to examine our hostile neighbor's atmosphere in greater detail. These probes, which typically weighed around 2,000 pounds, 900 kilograms, each had a number of instruments as well as a detachable pod, known as a descent module, that was fitted with a different set of instruments. These instruments included a barometer, a radar altimeter, gas analyzers, and thermometers. But not all of these investigations were successful. On March 1, 1966, Venera 3 slammed into Venus instead of making a scheduled landing there, making history as the first spacecraft to strike another planet. On October 18, 1967, Venera 4 took readings for more than 90 minutes as it gently descended through Venus's dense atmosphere. It also discovered that there was no global magnetic field and that airborne carbon dioxide levels were quite high. It eventually perished under the planet's extreme heat and pressure, as was to be expected. The Venera 5 and Venera 6 missions, which parachuted through Venus's atmosphere on May 16th and 17th, 1969, were both successful and transmitted data for more than 50 minutes. The romantic notion of Venus as an earthly paradise was destroyed as a result of these probes' assistance in further characterizing the atmospheric composition of the planet. With substantial armaments so that it might withstand the hostile conditions on the surface, Venera 7 contained an even more ambitious descent module that was intended to make a smooth landing on Venus. The flight, which was launched on August 17, 1970, had some success. On December 15, 1970, the lander succeeded in reaching the surface, but only after its parachute tore, causing it to fall more quickly than anticipated for over 30 minutes before slamming into the surface at around 38 miles per hour, 61 kilometers per hour. Despite being first believed to have failed, Venera 7 was able to provide useful data for a short amount of time. A brick pizza oven would be almost as hot as the surface temperature the lander observed, which was almost 900 degrees Fahrenheit, 475 degrees Celsius. Researchers were able to estimate a surface pressure of about 92 bars using measurements from the probe's pressure sensor, which failed during descent. This pressure is roughly equivalent to what you would experience if you were more than a half mile, 900 meters underwater. Surprisingly, Venera 8 was able to make some important geochemical contributions that further support Venus's status as Earth's sister planet, despite our inability to observe the planet's surface from space. Venera 8 also made some eye-opening discoveries about the visibility on Venus's surface. Not only was Venera 8 the first entirely successful landing on another planet, but it was also the second artificial object to touch down on Venus. On March 27, 1972, Venera 8 was put into orbit with the goal of measuring Venus's atmosphere and surface. In 118 days, it arrived on Earth. The measurements of Venus's atmosphere made by Venera 7, which despite difficulties with its landing, was able to report that the atmosphere was 97% carbon dioxide, were to be verified by Venera 8. Additionally, it noted a pressure of 9.0 megapascals and a surface temperature of 887 degrees Fahrenheit. These measurements made it clear right away that Venus has no water and is not a place where people could live. The measurements taken by Venera 7 were confirmed by Venera 8. However, due to its relatively smooth landing, something unexpected was discovered by Venera 8's photometer. The visibility on the surface of Venus was actually comparable to that of Earth on a cloudy day, and it was possible to see roughly 1 kilometer in each direction, despite the fact that it was difficult to see through the hazy Venusian atmosphere to the planet's surface. At a great height in the sky, clouds were seen. Engineers working on the Venera project discovered it would be possible to take a picture on the surface after Venera 8 arrived. As a result, Venera 9 made history in 1975 by becoming the first lander to take pictures of the surface of a planet other than Earth. Thorium, potassium, and uranium concentrations in Venus's surface material were also measured by Venera 8 during the 50 minutes and 11 seconds it took to relay data after landing. These elements are trace elements on Earth, which means they are found in basalts like those in Hawaii or at mid-ocean ridges, and in small amounts. The Soviet missions Venera 9 through Venera 12, which each weighed around 5,000 kilograms, 11,000 pounds, are the ones that are most well remembered today. This is mostly because their landers had cameras that could capture images of the ground directly. One of the most inhospitable settings in which man has placed one of his robots to work is the surface of Venus. The temperature was 905 degrees Fahrenheit, which is more than twice the melting point of tin, according to Venera 9. Conventional radio circuitry would melt at that temperature. The paper would catch fire, and it's possible that pools of molten lead would be met. The probe also noted atmospheric pressure at a level that was 911 times that of the Earth. The early images captured by Venera 9 and 10 are unsettling. They show an arid and rocky alien terrain that stretches out beyond the horizon in sharp, crisp, and spherically deformed images due to their wide-angle lenses. However, the photos also managed to capture the lander's edges, revealing their uniquely Soviet design. Both Venera 13 and 14 were more advanced versions of the Venera 9 through 12 probes that were launched in 1981. They carried landers that were outfitted with sophisticated acoustic instruments that could tune in to the Venusian wind and measure its speed. Both Venera 15 and Venera 16, which each weighed somewhat less than 9,000 pounds, 4,100 kilograms, lacked landers. They replaced them with extremely sophisticated radar-based imaging equipment that could survey the scorching planet from eccentric orbits. Though Venera 15 and 16 achieved a resolution of around a mile to 2 kilometers per pixel, Pioneer 12 may have been the first mission to map Venus using radar. These probes sent back incredibly clear photographs that showed vast areas of the rough terrain, complete with impact craters, towering elevations, and lava-filled basins. So, what has rekindled our curiosity about the planet? It's just the plain reality that Venus is very similar to Earth, despite its scorching heat, crushing pressure, and dense, corrosive clouds. Since ancient times, Venus has been viewed as Earth's twin, whose life went disastrously awry. In the solar system, Venus and Earth are neighbors and are almost identical in size and mass, as was mentioned earlier. The solar nebula creation should have distributed rocks and volatiles in roughly equal numbers to both. But it appears that their evolutionary trajectories were very different. Why have they separated into such disparate realms is the question. Was Venus simply unfortunate, or did Earth just happen to be lucky? Is it typical for planets in orbits like Venus and Earth to generate thick carbon dioxide atmospheres that trap solar energy and cause runaway greenhouse effects, or was Venus's a unique development? That's why we're going back, to find out the answer. Venus may have once been even more like Earth than it is now. Venus is believed to have had liquid water and hospitable temperatures on its surface for a significant portion of its early life, until a runaway greenhouse effect turned it into the hellscape it is now. Venus might have just been in the wrong location, though. It was a little warmer when it originated during the solar system's formation 4.5 billion years ago, because it was 67 million miles closer to the Sun than the Earth's 93 million miles. As a result, unlike on Earth, where our oceans were crucial in absorbing carbon dioxide and preventing runaway greenhouse warming, the water vapor in its atmosphere never condensed into oceans. Currently, astronomers are looking for small, rocky planets like Earth that orbit stars at a distance where liquid water is expected to exist in order to locate viable planets that might support life elsewhere in the galaxy. Venus is the only other planet in our solar system that is located in such a region, so perhaps that location isn't that promising after all. In other words, if Venus is the norm and Earth is the exception, we might find that such planets are much less likely to be hosts for extraterrestrial life. Learning more about that metamorphosis may help us better understand how planets evolve and may also provide light on how climate change affects Earth. The orbiters and landers being developed by ISRO, Roscosmos, ESA, and NASA will be helpful, but they cannot give a complete picture. In order to gain those insights, however, detailed studies of Venus are required. Landers are constrained to their landing spot, while orbiters are forced to observe from a distance. We must approach the surface closely and study its variations in order to fully comprehend it and how it has changed over time. We may gain a better understanding of the distribution of livable worlds throughout the cosmos and the evolution of habitable planets in general by studying the evolution of Venus. Determining how much water once existed on Venus, for instance, should be possible by examining the levels of the hydrogen isotope deuterium. And determining whether the planet once supported liquid water may be possible by analyzing noble gases like argon and neon in the atmosphere. These analyses will be crucial in revealing Venus's journey toward the dark side. To put it another way, we must investigate it. We might learn a lot more about Venus's geology and how it varies across the planet's many areas if we had the capacity to roam about it. Nevertheless, the combined findings of upcoming missions will provide information about the planet, from the clouds in its sky to its volcanoes on the surface, all the way down to its core. The planet will seem to have been rediscovered. Even yet, the Soviet Union's Venera program continues to be the longest, most intensive run of Venus missions.